Welcome back. This is an Aleks training video on interpreting the electron configuration of a neutral atom in noble gas notation. Noble gas notation, you like this because this is shortcut. This is not long cut. Noble gas configuration means you do not have to write dozens and dozens of letters as something gets bigger and bigger. So let me show you this again. If you have helium, we're done at 1s2. Okay? If you have carbon, you're done at 1s2, 2s2, 2p2. Okay, that's not really long. But if you have something like mercury or bismuth, okay, something huge, or down here that you have Einsteinium or Mendelevium, these are long because you have to do all the S's and then the P's and then the next row and then all the SP's, D's and next row and next row and next row. It just gets longer and longer and longer. A noble configuration simply allows you to use a noble gas and then keep going after the noble gas. Like it's the configuration of, say, argon plus more. That way it's not 100 miles long when you want the address. It's just too hard. It's like Roman numerals. It just never end. Okay, so we're going to do a configuration and then see that it's actually easier. So we want, what is the configuration of neon 3s2, 3p2? All right, let me give this back to you. All right, so we're going to go to neon, which is already 10, and now keep going. 3s2, so I go down to the third row. 3s2 is full, so magnesium, it's more than magnesium, and then more 3p2. Here's 3p1 aluminum, 3p2 silicon. Okay, so they didn't write 1s2, 2s2, 2p6, 3s2, 3p2. They made a shortcut and just put the noble gas on the previous row from where we are. So we're going to be here at silicon. So they put neon in brackets. Okay, so you have Ne brackets plus the next plus the next. Okay, so this is going to be silicon. Now once we get to silicon, be looking at a periodic table, please. What's the chemical? Okay, I should have written it here. Silicon. How many electrons does it have? Now silicon is atomic number 14. It's a neutral atom, so that means the electrons and the protons are the same. So this is going to be 14, just like the protons are 14. How many 3p electrons are in the atom? All right, so this is an easy question. You just go to 3p. How many are listed? 3p is the last, so it's not going to be full in this case because silicon doesn't go all the way to 3p6. It stops at 3p2. So that means there are 2 3p electrons in the atom. Okay, so this is very much like we did before, only it's a shortcut, and it even gets better when you have to write these because you don't have to write long ones because you can just do a shortcut with brackets and then just keep going with the last part. Okay, thanks.